Imagine playing your favorite role-playing game. You finally saved up enough gold, and your character bursts through the wooden doors of the local blacksmith shop, ready for a major gear upgrade. You walk up to the counter and order the ultimate protective gear, the complete futuristic spacesuit. But when the blacksmith hands over your items, something is deeply wrong. You get the space chestplate, thick medieval leather gloves, and a plastic bicycle helmet. Behind the screen, every item in a video game is generated by code. So how do programmers write rules to guarantee that when you ask for a specific suit of armor, you actually get a perfectly matched set? To solve this, programmers look at how the code organizes the creation process. They use a concept called a factory, a specific part of the program dedicated to building objects. But as we just saw, if these factories work in isolation, the result is a total mess. Let's step behind the scenes and look at how a game actually organizes your character's gear. Before any armor is even created, the game sets up an inventory layout. These silhouettes act as a universal interface, a set of rules that says only a helmet fits in this specific spot. The slot itself doesn't care what the helmet looks like. It just provides the empty shape that needs to be filled. To fill these slots, developers build a dedicated creation box for each type of item. Think of these as small, specialized machines. One box is programmed only to make helmets, another handles chest plates, and a third crafts gloves, dropping them right into place. But here is where the blacksmith's mistake happens. If each of these little boxes is working entirely on its own, they aren't talking to each other. The helmet box might produce a medieval knight's helmet, while the body box makes a modern t-shirt, and the hands box spits out futuristic robot claws. These individual boxes do exactly what they are told, making one specific thing, but because they can't coordinate, they ruin the player's experience by creating a mismatched character. This schematic shows the real solution, the abstract factory. Instead of letting the smaller boxes run wild, developers build a larger master machine that wraps around all those individual item makers. On the front of this master machine is a single controlling dial. This dial dictates a unified theme for every single production line housed inside of it. When the dial is switched to futuristic, it sends a command to every machine inside. They are now locked in. The helmet, body, and glove boxes coordinate to output only matching neon blue laser gear. If we twist that dial over to medieval, an immediate shift happens across the board. The internal boxes simultaneously stop making laser gear and instantly start producing iron and leather items. By forcing all the individual item makers to take their orders from one central authority, the abstract factory prevents those awkward glitches. It ensures visual consistency across a whole family of related products. Let's head back into the game world. With the shop's code properly organized, your character steps up to the counter and once again asks for the futuristic's ace suit. This time, you receive a perfectly unified suit of glowing neon armor. Every piece fits the same aesthetic, and that messy, mismatched look is completely gone. While we've been talking about video game armor, professional developers rely on this exact same strategy to build the phone and computer applications you use every day. Think about the buttons and menus on your screen. An app needs to look sleek and rounded on an Apple phone, but sharp and square on a Windows computer. This logic flowchart shows how an abstract factory handles that challenge. When the app starts on Apple, the switch routes to the Apple path, generating a complete family of matching rounded buttons and sleek menus. If it detects Windows instead, the switch moves, instantly producing a cohesive family of sharp-cornered buttons and blocky menus. The abstract factory acts as an invisible coordinator. It ensures that no matter what environment you are in, the digital pieces always match, keeping our software organized and our digital worlds consistent.